Hello everyone. In the previous videos we were discussing MPMC PTU May 2019 paper. We have discussed all the questions of section A. So now we will discussing for section B. We will be starting with the second question, that is the components of 8085 architecture with the use of block diagram. So first of all we will start with this question. As you all can see that this is a block diagram of 8085. So first of all we need to draw this block diagram. So now when we will be understanding this diagram, it will be easier for you to remember it and to draw it. Now from the block diagram we can see that this is the internal architecture, that it has been divided into basically 3 units. Now first unit one is the ALU, second is the timing and control unit, and third one is a register. So basically these are the main units in which our block diagram has been divided. So we will be discussing each unit one by one. So first of all we will start from the ALU, that is the arithmetic logic unit. It is now one of the basic unit of microprocessor. So all the computing functions, like all the arithmetic logic operations, are performed by this unit only. For example, if we want to perform addition, subtraction, we want to perform any increment, decrement, any logical operations like AND or XOR, all these operations are performed by this unit only. So now what happens is that it gets its input from accumulator and one from the temporary register while performing any of the operation. It is one of the basic condition of this unit that the one input should be from the accumulator only, and the second one can be from any of the register, like it can be from register B, C, D, E, H, L. It can be from any of the register, and whenever it performs the operation, ALU stores its result also in accumulator. So from this you must be clear that what is the function of ALU. What ALU is doing is it is performing the operations, taking its input from accumulator and second input from the temporary register, means any of these registers B, C, D, E, H or L, and it's storing its result in accumulator only. Okay, so this was arithmetic logic unit. It is also arithmetic logic unit is of 8 bits. Okay, now we move on to our second unit, that is the timing and control unit. Now what is the function of this timing and control unit? Now all these single pins will be discussed in the pen diagram only. So if you are getting the question for 10 marks, if you are having time and if you are having space, then you can write these units, means one line you can write for this pin diagram. But before that, first of all you will be going through all the architecture, then you will be going to the minute details. Okay, so in this video, first of all we will be going with each of the unit. So first, for this one is the timing and control unit. It is one of the another important unit of 8085. Now what is the function of this unit is that it is controlling all the entire operations that are performed between the microprocessor and the other devices that are connected to it. Means whatever data will be flowing between the microprocessor and the other input, that will be controlling by this timing and control unit. Now it is the timing and control unit which inform the other unit that your task has been come. Suppose if we want to perform any addition, and one value is stored in register A and one value is stored in register B. So the control signals that will be sent to register A, that to ALU and to register B, all these signals will be sent by the timing and control unit only. So basically we can say that whenever any instruction comes, the instruction enters the processor and execute all the task is done by another unit, but actually it is controlled by timing and control unit. Means it is overall controlling, it is overall managing the execution of the instruction. So you must have got the idea what is the function of timing and control unit. Now we move on to another part, that is the registers. Now but actually register can hold any register is you can say that it is a small set of data holding places. Means our data is held in the registers only. Now it can hold any instruction, it can hold any address, any kind of data it can hold in registers. Basically we have divided our registers into 2 categories: general purpose and special purpose register. First of all we will be discussing the general purpose registers, then we will be moving to special purpose. So for general purpose register, these are holding the data that are used by the program whenever any instruction is executed. Now we are having total 6 8-bit general purpose. All these registers are 8-bit. So all the register B, register C, D, E, H and L, all these are general purpose registers and are having a size of 8 bit. Suppose if we want to use if we want to perform any 16-bit operation, then we can use them in pairs, but it is fixed that register B will be used with register C only, register D will be used with register E, register H will be used with register L only. We can't use register B with E or C with D. Basically these are 8-bit registers which can hold any data or any address these can hold, and if we want to perform the 16-bit operation, then we'll be using these registers in register pairs. So this was the general purpose. Total we are having is a 6 general purpose registers. Now one thing we need to find is that we are having memory. So memory, there for the point for memory means when we are having the memory, we are having the memory address also with it. So whenever we want to point to the memory address, when we want to find a recent memory address, that memory address is given by register HL. Means whatever value will be of register pair HL, that will be considered as the memory pointer. Means current memory location will be given by register pair HL. So this was general purpose registers. Now we move on to special purpose registers. These special purpose registers are like they're performing some special functions or are containing some status of the processor. Now first one we come on to accumulator. In the previous unit we have discussed in ALU, accumulator is a 8-bit register. Whenever we are performing any operation, then one input should be from the ALU, and when the operation has been performed, it is storing the result also. Now it can send or receive also data from this 8-bit internal bus. Now second special purpose register is program counter. Now what is program counter? It is also known as PC. Now all these single registers are of 8-bit. Now all these remaining 3 of 16-bit. So program counter is of 16-bit register. Now it holds the memory address. What it is holding? It is holding the memory address. Of which memory address? Of the next instruction to be executed. I repeat, program counter holds the memory address. It is holding the memory address